Okay, so this module number 2 is about describing data visually and describing data numerically. These are the two things that we would like to learn. So how you can see the data visualization, how data visualization can be possible using different charts, graphs, tables. So these are the tools for data visualization. What are the describing data numerically? Mean, mode, median, all the univariate analysis, they are under this. So why we are doing this? What is the purpose of this? The purpose is to have 4 characteristics, to understand the 4 characteristics of the data. Measurement, what are the units of measurement? Are the data integer or continuous? So for example, in Minitab, we have unit of measurement, age is years. For example, fair in pound is, fair is in pound sterling. Yeah. So that is measurement. Center, where the data values are concentrated. So where is the center? What seem to be typical data values? So that is what we are interested in. Variability, how much dispersion is there in the data? How spread out are their data values? Means, for example, you can see if you have, can you click continue on your screen, please? Oh, can you see my slides?
We can.
Okay,
Yeah.
so what else, Karen, do you want?
I think it was the message consenting to continue with the meeting when you started recording. Somebody's having some issue with just clicking that button.
Okay. Okay, so, okay, I'm continuing. Okay, variability, how much dispersion is there? So you can see the dispersion in fair in pound, it starts from 0, goes up to 500 some pound sterling, 512, I believe. Are they unusual because only one person who paid this much money at that time in 1912 or 1918? So this much money is like hundred of thousands of dollars.
Join the meeting.
So say, are the data values are distributed symmetrically? Are they skewed left, right? You know, this is all we would like to see in data. Therefore, we have this. Now after this, very first thing is, you know, Esteem and Leap that we have studied in our school days, like kindergarten or, you know, middle school. What is the Esteem and Leap? So front number is Esteem and then Leap. So for example, this is all the data, 44 price versus price earning ratios. So here you can see these are Esteems is 0 and 2 numbers are there, 7 and 9. First you arrange them in order. So 7 and 9, what is before 7 or what is before 9? It's a 0. So Esteem is 0 and Leaps are 7, 9. Similarly, in tens, how many values are there in tens? You can see these are the values. So similarly, 1 and then 0, 0 up to 19. So 2 19s are there, 2 18s are there, 2 17s are there, 4 16s are there, 1 15 is there, 2 14 is there. So this is called Esteem and Leap representation, and that we learn, and Minitab does it very quickly. So I'm just going to demonstrate Minitab also right here. Okay, I think you can see my screen. Minitab.
Yeah, I can see it.
Okay, so what is happening here? Let me graph. We have Esteem and Leap. So I'm just going to put age, or, you know, okay, you can see this is Esteem and Leap of 2000 for N is 28s are missing, and Leap you can see, we have to make it bigger in order to understand. So for a small data you can see, but for larger data it will mess, but still you can see for zeros here you have large numbers. So this is simple representation of Esteem and Leap. Similarly, basic you go under graph, we have dot plot, and here you can see, so you can see the dot plot, and you can see in particular age how many people are there. Let's say I'm just picking these 20 number. In 20, how many people are there? So I mean, it's typical. 30, how many? You can clearly see in what age most of the people were there. And you can see these are the outliers, after 70, 69 or before that. These are the few unusual people. And you can see the very first one is very small, which is just like, newborn baby. So this is, now after this, we come to the Sturger's rule. How many bins are there in, or how many bins we can classify, how data can be classified, and how many possible bins should be there. There are two rules. One is 2 to the power k rule, which we don't have in our book. Therefore, I don't want to tell, otherwise you will get confused. And this is Harvard Sturge's rule. And here it says, if you have up to 16 sample, you need 5 bins. In between 60, more than 16 and up to 32, there are 6 bins. 32 to, so 64, above 64, up to 128 is 8, and so on and so forth. And suppose these are limited numbers which are given here, right here. However, suppose you want to calculate that, how you can do. So this is the simple rule. I think you can see my whiteboard also now. Equal to 1 plus 3.322 log n. N means number, like I have asked one question up to 62. There's a 62 numbers, and how many bins would be there for 62? Certainly, it is more than 32 and less than 64. So it would be 7 bins would be there in that case. For example, we are doing this 2,478 numbers. How many bins will be there? So you have to plug these numbers in simple calculator. 3.322 log and 2478. So you can get the answer. There's no hard and fast rule in Sturger's rule. What you can do, let's say the calculation is coming, because calculation will come in decimal, 2.3124. So it is not hard and fast. You have to, because bin is discrete number. As you know, we talked in previous lecture, what can be discrete, what can be continuous. So bins are not continuous, they are discrete. So either it could be 12 or it could be 13. We can't have 12.3124 bins. So, if you go for 12 or if you go for 13, both are the correct answers. So we are not hard and fast related to that. Or, you can modify the bins as per your requirement, or as per your, decision requirement. Now I'm going back on my slide part. Now, similarly, so how many frequencies are there? What are the frequencies? So here you can see between 0 to 10, how many frequencies are there? 2, 10 to 20, 24. So this is the win limit, means it starts from 0, less than 10. It start more than 10 and less than 20. And how many frequencies are there? Relative frequencies are there. And relative percent of those frequencies are there. And cumulative percents are there. So cumulative percent is right here. So this is the way to write, describe the histogram. Histogram in what bin, how many people, how many numbers are there. So look into that. I think you can see my Minitab because I will be keep doing multiple times. So histogram is like, I can just go, I'm just keeping. So this is the histogram. If you can see under graph, all the charts are there. So I'm just again doing histogram. Okay, by default, I don't need to do anything. This is by default, but these are too many bins. I would like to adjust as per our Sturger's rule. So I just did it. Here we have binning option, and you can just do it like whatever, like I would like to do 15, automatically it will convert into 15. Now I would like to see in the histogram how many people were there between age 20 to 30. But here I can't see, so what I need to do, I just go here, I do edit bars, binning. I would like to see cut point here, and here I have to give the manually cut point. So first I'm going to give 5, I'm just going to do, first is 5, second is 10, third is 15, fourth is 20, fifth is 25, then 30, then 35, then 40, then 45, then 50. What we were asking, we were looking 25 to 30 or 20 to 30. So I just removed this. So we were looking between 20 to 30, how many, and 50. Now next is 60, and now last is 75. Oh, so you can see my purpose has been solved. Here between 20 to, now again add data levels. Oh, sorry. And use by, and now you can see the, so my question was how many people were there between 20 to 30, and I can clearly see these are 877. How many people between about 60 plus 60 to 75, 46. And we can, between 50 to 60. So we can do this as per our requirement. If you would like to see the customer profile in your store, if you have reward member, or if you are working with customers, or in any store, you can see who are the customer, in what age, what is their amount of purchase. Let's say, you are in Costco and you have membership number, and you can see all the customer, how many customers are there, those who spend between $500 to $1,000 each month. And you can clearly see, out of your total customers, you can see there are 10% of customers, those who spend this much money. And you can see who are the customer who spend more than 5,000 per month, or who are more than 50,000 per year. That you can, you can see, then you can go with different promotions to, you can approach to them with different promotion in order to be, you can retain their loyalty, you can retain them, or you can, give them some bonus or some, you know, points or reward or coupons. So this is very simple tool, very simple way in order to you know, see where you have, who are the customer, those who spend only $100 per month. Okay, how we can push them to, you know. So this is the simple tool that you can use. And after this, 6 means, so histogram is, rest you have already. The histogram can be different ways, you know, it can be unimodal, bimodal, multimodal, and these are the all types of possible types of there. Left skewed is the one which has tail towards left side. Unimodal means you can see only one, you know, model is there. Symmetric means both tail are symmetric. Skewed right means tail is towards right side. Similarly, bimodal, two modal, left tail, two modal, right tail. Symmetric, multimodal, and symmetric means both tail are symmetric, it has multimodal. Similarly, you can say skewed left with outliers, means it is left, but you know, these are the outliers which are not connected. Skewed right with, so these are the possible shapes of uh, distribution. Or, you know, now we have polygon and ogive. So what is polygon? Polygon is nothing but, you know, percentage. For example, this is just when we did relative frequency, relative percentage here. So this is the, if you plot this against ratio with percentage, you can see this is, when you do it cumulative, that is ogive. Cumulative means it is always increasing. It adds the previous values and it goes up to 100%. So this is ogive, and simple line chart that you can clearly see the time series and, you know, the dollar per month or whatever, you know, unit you are measuring. So 2-line per chart that you can do easily on a Minitab. So I'm not, you know, going to explain here. Another chart, very important chart that is used in management, which is pie chart and bar chart. Let's say I have 4 PhD students and 2 are from India. Let's say I'm just going to, can you see my slides?
Yeah, I can see them.
Yes.
So 2 of them are, let's say, from India, one is from USA, and one is from Africa. So I won't say, you know, in management, you know, a smart way is that I won't say I have 4 PhD students, they are working with. I will say in terms of 50% my students are from Asia, 25% of my students are from USA, and 25% of students are from Africa. So this is the way, you know, always they don't show real numbers. They say 5% growth, this, you know. So bar chart and pie chart, but there is a limitation of pie chart. Pie chart cannot be done on, like, you know, these many categories. I mean, these many too many categories. Pie chart has limitation that you can do up to, let's say 5, 6, whatever clearly visible to you. So that is simple bar chart is like this. So for example, we have simple bar chart in our case. For example, status is the, where different status of the passengers are there. So I'm just going to do, let's say I'm going to do pie chart here, and where is a status? Right here. I'm just going to put the levels right here, not percentage. Okay, so I'm just going to do here, and let me clear all the drawing. So right here you can see these big, you know, pies, you can see clearly. However, these pieces here I can't see, I can't distinguish, I can't understand because these are too many. Therefore I need to go under this. Oh, sorry, graph, and then we have pie chart right here. And I just go under status and okay, right here. So this is the bar chart, which I can clearly see. However, I can make it more, attractive with numbers, percentage and all. So I just right click here, edit graph, and I can do edit bars, chart options, increasing order. So Y as a percentage, and right here, add data levels. So I hope you can see this. So this is highest passenger 52%, and postal is least people, musician. You can also place the number instead of that. So this is the another way of, so if you have too many categories, use the bar chart instead of pie chart. Now there's another thing which is very important in operations management or quality control, which is called Pareto chart, or the way you pronounce it. It has two things together. One, you can see bar chart, and second is Ogive. And when you study that, there are few reasons. If you 80, it is also called Pareto chart, it is also called 80-20 rules. Means 80% of problems or 80% of performance can be improved if you fix 20% of issues. So if you, for example, here in this chart, you can do food cold and too much time in line. If you reduce these, your 80% performance can be increased. So 80% performance depends on 20% of reasons. So if you fix these 20% of reasons, 80% performance can be increased. So here is stepped column chart, all these you can do in Minitab, all pie chart, scatter plot. A scatter plot has two variables. We were talking about only till now one variable, which is univariate analysis. When we deal two variables together, that is called bivariate analysis. And when we do two things together, it is called bivariate, or scatter plot is the example of this. So I'm just going to demonstrate here. Graph scatter plot. Okay. So what is the Y variable? So we have only two numerical and fair in pound. I mean, we can't get any pattern here. It is no relationship, no thing. So, but if we have the real data, we can see, and I will demonstrate in coming classes. So it is a scatter plot. So basically a scatter plot is also represents correlation between two variables. If X is increasing, Y is increasing, then, and it is coming close to a straight line, it is a strong positive relationship. It is close to 1. Similarly, if X is increasing, Y is decreasing, that is called a strong negative. If you see no pattern, or if you see different kind of parabola, curve, hyperbola, or different, curvilinear or different type of shape, that is non-linear pattern. Here, this is close to positive or negative line, but here, you can see the trend, but that is not strong. So this is weak positive and weak negative. So we will learn, correlation in chapter number, I believe, in hypothesis testing, before testing the. And the last part is tabular description. So visualizing data, summarizing data in tables is also one of the visualization tool. So if you are big, you can do pivot table and cross tabulation. That is all visualizing the data. So you can see in this table, you can understand all the figure very easily. So this is chapter number 3. Now we are going on chapter number 4. So here chapter number again 4. Why we are doing? To see the center, to see the variability, to see the shape. So these are the objectives of doing chapter number. And now very first thing, mean, mode, median, we know all What is mean? Mean is nothing but average. One more thing I would like to throw a light here. Populace, always think, you know, there's a diagram in book. Population mean is always represented by mu, and sample mean is automatically by x bar. So whenever you see these symbols, you can understand which one is population, which one is sample. So there are few notations we have to understand, you know, always keep in mind. For example, this is for population and this is for sample. Capital N is population, small n is sample. Sigma, standard deviation population, small s, standard deviation of sample. Then mu is mean or average of population, x bar is pi is proportion of population, p is proportion of sample. So these are the notations we must, you know, always keep in mind, because sometimes you get these numbers and you should understand this. And after this, we understand what is mean. Mean is nothing but simple average. What is the median is very important to understand. Median is where 50% means where the point where data can be divided into two parts. The data, for example, this is the data. The center point from where the entire data is divided into two parts or two pieces. 50% left side, 50% this right side. That is called 50%. So this is median. Now since you are already into this, I don't need to explain here more about this. Another important property, when mean equal to mode equal to median, this is symmetric. You can see the same. When mean equal to mode equal to median, this is ideal curve. And if mean value is given, mode value is given, and median value is given, you can easily understand what kind of data is that, what kind of curve, what kind of, you know, distribution is that. So if they are close to each other, you can say that is almost symmetric. Skewed left, mean is smaller, median is central, mode is high, then it is skewed left. And if you see the mode is smaller, median and mean is then skewed right. So this is another way of doing. And what is mode? Mode is most occurring frequency in any data. So for example, in our this Titanic, so I'm going to do once, you know, once we will finish little bit about theoretical, then we will do all the things. This is very important aspect that every one of you have to have whenever we are doing any financial or economic progress or growth related calculation. We are not using simple average or simple mean. We are going to use geometric mean. So this, for example, what is the average growth in last 5 years of US GDP? So for example, 2.5, 2.4, you can't do all the average. You have to use this formula, which is called geometric mean. For example, here, the revenue from 2006 to 2010 is right here. And this is JetBlue Airlines. So what is the geometric mean? Square root of 4 times this is -1, which is this. So which is in terms of 12.5% per year. So this is very simple calculation that you can have. You can, you know, I mean, being a manager, you always keep this concept in mind whenever there is a need of average growth or average financial progress or any aspect. You can see your own, for example, what was your salary in 2008? What is the, let's take only 5 years, 2015, 16, 17, 18, 19, 20. What is your average growth over a 5 years of timeline? So you can put your salary from W2 form 2015, 16, 17, 18, 19, 20, and you can see yourself. So this is, your own question to see your own progress in terms of your how much growth you have achieved over a 5 years. So now measure of the mid-range is the point halfway between the lowest and highest value. So it is not median, it is center point from highest value, midpoint between highest and lowest value. So highest plus lowest divided by 2, which is midpoint or mid-range. So range you can understand, range is maximum value minus minimum value. Now, very important concept. I believe you have watched my video of standard deviation, which is very, 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 very important, because standard deviation and mean, these are the two statistics tool or statistics calculation we are going to use in most of the statistics related aspects. So don't forget to have. Do you get a chance to do that or not? Or should I explain again? I did not.
Maybe explain again.
I wouldn't mind
Okay, so what
explaining.
is mean and standard deviation? So basically, this is variance and this is variance and standard deviation. These are the two things. So let me go. So what I do, like I take an example of age of, kindergarten students or, elementary school. So we don't want to go like, 20 or because many students, because software does automatically. I'm just manually explaining. I have 5 students. The age is, one student is 8 year, one is 6 year, one is 7 year, one is 5 year, and one is 4 year. So basically, what is the deviation? Basically, it is how the values are deviated from the center, from the mean. This is what is standard deviation. So how it is deviated from the mean, this is what we are going to check. So this is 8 plus 6, 14 plus 7, 21 plus 5, 26 plus 4, 30. Divided by 5, so we get 6 number. I mean, the average is 6. So I just subtract this from 6th. This also 6, 6, and 6. What value we get here? 2, 0, 1. Here we get minus 1. Here we get minus 2. Now, if I sum all, what I get? 2 plus 1, 3, minus 1, 2, minus 0. It doesn't solve any purpose. So there are 2 operations we can perform. Number 1, we can make absolute value. Absolute value is, this is the notation. So 2 absolute value is 2, 0 is 0, 1 is 1. Absolute value means we don't, regardless of sign, negative or positive, all values are positive. So 1 is 1, 2 is 2. What we get here? 6. 2 plus 3 and 3, 6. But here this we will use for mean absolute deviation. This is, we will use for mean absolute deviation. Now I go further. I don't need this. I am going to do a square of this. So 2 square is 4. 0 square is 0. 1 square is 1. Minus 1 into minus 1, which is plus 1. Minus 2 into minus 2, plus 4. And what value we get? 10. 4 plus 4 into 2. So if you can see my, I think dual screen. Can you see my slides also? No.
No, we cannot.
No.
Okay. So I have to flip back and forth. No problem. So now can you see the slides?
Yeah.
Yes.
So you can see the sigma square is equal to I equal to 1 to n x minus mu square divided by n. What is x is, you know, individual value, mu is average for population for sample, mu and x bar divided by capital N number of. So this is the formula of variance. This is the formula of sample variance and population variance. Now I come back to, so I think, so this upper value we got already 10, and we have this, how many observation we took? 5. So this value is 2. So this is sigma square, means variance is 2. Suppose we would like to do for sample 10 divided by 5 minus 1, which is 2.5. So if you see, you know, whenever calculator or some computation, you see the 2 standard deviation. One is for higher value, lower value is for population and higher value for sample. Reason is that because here is the denominator is smaller, here is 1. So here denominator is 1 minus, which is smaller, than total value will be higher. So this is 2.5, this is 2. Now I go back on my, so this is variance, and now we want to get the standard deviation. How we can get? So we remove the square sign from both the side. Then what will happen? The entire number will be under you know, square root. So what would be the value now? So 2 will become a square root of 2, and 2.5 will become a square root of 2.5. Therefore, standard deviation in this case is 2. For population, this is 2.5. Now let me explain on whiteboard again. So I hope now you can see my whiteboard. So look into this. This is the standard, this is the 10, you know, 2 sigma square, or I will write here variance equal to standard deviation square. So this is the relationship, and any future example or problem, if you get variance, you can convert in a standard deviation. If you have a standard deviation, you can convert in variance. So basically they are, you can see, correlated. Only, you know, square root and square is the difference between these, but they are the same otherwise. Now think about the concept here. So this is the deviation from the mean, means average age is 6. And what is the average age is 6 of this my class. Deviation is square root of 2. This is the, means this is the sigma value. Now think about, if all the students are of same age, I'm just overwriting, or let me clean then. Let me clean all the things. So let's see, this is all the students are 6. That means average is again 6. If I do minus 6, minus 6, minus 6, minus 6, and minus 6, what is going to be? 0, 0, 0. What do we understand? Can we do absolute value, or we can do absolute or square? It is not going to change anything. That means The standard deviation, what is going to be, or variance is going to be 0. What we want in real life? We want deviation, standard deviation from the ideal should be 0. I mean, this is our, so this data is less, this is ideal data. Practically 0 standard deviation we can't achieve in life because there is always, swing here or there. Our purpose in real life, if sigma value or sigma square value is as close to as 0, that means consistency in data observation is there. So there is a word called Six Sigma. If you hear, I'm Six Sigma certified. So Six Sigma, if you hear this word, this is quality. It says 3.14 defects per million. Means in 1 million products, only 3 or 4 defects can be tolerated. This is a quality which was invented by Motorola. Now I think across the world, everyone, use this Six Sigma concept. And I will explain what is the Six Sigma in coming slides. So this is the important concept that we can take. For example, this is the, I think I normally give airways runway of the airport. This is the standard line. Means this is the always the front landing gear of every plane. Those are landing or taking off. The front landing gear must follow this line. Away from this line, for example, the one plane is landing and the front landing gear, that means it has risk. This much risk is there to go out of the runway. B condition is this. This has bigger risk than first case, and this has C case which has biggest risk among 3. Where you don't have risk when it is exactly or ideally, and aviation industry follow the Six Sigma, because out of 1 million flight take off and land, only 2, 3 or 4, they, or even less than that, skid out of the runway, or they have some issues, or otherwise this is the one. Motorola, many companies, they follow the Six Sigma. So this is the concept of the Sigma, that, sigma standard deviation should be close to 0 or as less as you can have. So clear all drawing. Is it clear to everyone? So now here we have also mean absolute deviation. What is mean absolute deviation? That we did absolute value of the same numbers. I have to go on slide part. Can you see back the slide?
Yes.
Yes, Kate, we will do everything. I'm just explaining the concept, and then we will do everything right in the Minitab. So mean absolute deviation, we did, 6 for 6. This is another, 6 divided by 5. So mean absolute deviation is also the measure of dispersion. Measure of dispersion is mean absolute deviation. How much it is coming? 1.2. So this is the, now here another coefficient of variation is called 100 multiplied by 100 for percentage. S means standard deviation, X bar means mean of the, so this is another. So this is central tendency. So let me go for standardized concept here. So let me go this. So if you can understand, this is most important slide that I am going to throw here. So this is mu. Let me go now on Minitab first. So this is mu, which is average. Average plus 1 sigma. average minus 1 sigma. So 1 sigma from mean here, 1 sigma from mean here. This is called 2 sigma. The 2 sigma value is 68.26. Mu minus 2 sigma, mu plus 2 sigma, this value is called 4 sigma. The 4 sigma value is 95.44%. Mu minus 3 sigma, mu plus 3 sigma, this is called 6 sigma, and this is 99.73% data will be within 6 sigma, or almost range will be there. How we can understand? This is called empirical rule, and let's do the practical thing here. So I'm just going to do a practical with our Minitab Titanic data, and let me share with you the. Can you see the Minitab?
Not yet.
Yes.
Not yet.
Okay. Now I'm going under a graph, under histogram. I'm just using the second thing. And I'm just using age variables. Now I can see this is my histogram and this is my curve. And what is the mean? Mean is 30.92. Standard deviation is 11.96. Okay. And now let's do one thing, which is mu plus sigma and mu minus sigma. This is the first range. Let's do what is the mu 30.
Still not seeing Minitab.
Yeah, I don't see the Minitab either.
Okay, just a minute. Can you see now?
Yeah.
Okay.
Yes.
So what I did, I'm just going under graph. Under graph, we have where's histogram right here. Under this with fit, I'm just using the fit, and I'm using age. By doing this, I can get the the histogram and the possible curve here on the fitting curve here, and I can see the mean of this and standard deviation of this. So what I'm going to do now, I want to do mu plus sigma and mu minus sigma. What is the mu is 30.92 and plus 11.96. This is mu plus mu means this is sigma.
Excuse me, I can't see that very well. Is sigma actually listed on the histogram as a labeled number?
Can everyone see the Minitab?
I can see it, it's just small.
I'm
I can
just
see the
putting,
Minitab.
it's a full screen from my side.
Okay.
So look into this. And then second is 30.92 minus what is 11.96. So if I do these two calculations, what is the value I'm going to get? So let me do, okay. So I calculator, store result in C9, expression 30.92 plus, where's the plus sign right here, 11.96, and that's it. Did I do something wrong? Calculator, so result in this, and I don't want to do any function. I think anyway, I'm just going to do manually 30.92 and 11.96, which is going to be Let me use the simple calculator of Windows. So this is going to be, oh, sorry, 11.96 plus 30.92, 42.88. So let me write this, 42.88. Now I want to do the one is plus, one is subtract. So 30.92 minus 11.96. So we are getting 18.96. So the answer is 11.96. So empirical rule says plus within 2 sigma, how much data would be there? 68, 67, 68%. Now let's do practically. This is 18.96. I can roughly count 19, and 42.88 I can roughly count 43. So between 19 to 43, I should have almost this number in the data. Okay, let me do. So I'm just going to do this. I'm going to see age, and what I'm going to do, I'm going to sort here the age number. So I'm going to do data, and I can sort. I can do the age and all columns, specified column, and increasing order, and column C9. Okay, so this is sorted age, if you can see. So this is sorted age. Okay, it did calculation here, 42.8. Now I'm going to check from where the where the 12 age is starting. So 11, 11, 11, 12. This is started at 108 number. I'm just doing it manually, and we would like to see how much. 43, 108, 43. So here we have 43, 43, 43, 43, 43, 43. So how much? 2092. Now I would like to do a simple calculation here again. Calculator 2092 minus 108. 1984 numbers are there within 2 sigma range. Now let's do the proportion. How many people were there total? 2, 4, 7, 8. Am I correct? This is coming because we have a smaller. 80% data is coming within 2 sigma range. Approximately 80% data. Similarly, if you multiply within 6 sigma, you will get almost all the data except few. Within 4 sigma, 2 sigma this side, 2 sigma on that side, you will get 95.44% data. That is called empirical rule. So I'm just using 2, 4, 7, 8, and this data is manually. If you have real data of your Salesforce or anything, you can run this and you can get the real insight. So
would you mind showing us how to overlay the curve again over the histogram?
Would you like to share with?
Just the curve. How did you get that curve over the histogram? I have Minitab
I'm
up
going
and I have a hard time.
Share here. So basically I can do it here for you over there, that we will cover. So here under graph, histogram with fit. with fit. And
Awesome,
another way
thank
I'm
you.
going to share here, we have graph, but don't you know, as of now, don't do it, because, you know, so for example, this is the probability distribution, and view probability. I'm just going to do normal distribution. The mean is, what is mean? 30.92, and standard deviation 11.96. And the shaded area, I want two X values, which are right here. One X value is 43. The second X value, how much we had? 19. Was it 19 or? Oh, I just did, you know, you can see this is, I was counting from 12. So basically I had to count from 19, and then it will have. So how many, what percent of data is there between one minus 1 sigma and plus 1 sigma? So let's see here, 90 to 30. Here, can you see this right over there? 68.43%. I was just making, you know, 12 as a lower point, and we can do it manually. So here you can see, I hope you can see from 19. Therefore, I was just, yeah, this is 19 right here. What is the value? 19. This is coming 265. So I have calculator again, which is, I think it came 2092 minus how much? 19 is 265. How much we are getting? 18 divided by 2478. So this is coming with this real number, almost 73. So if you see in this 68.43% data, similarly, we can see for Six Sigma. I mean, if we know these values, or otherwise we can do a percentage also. So here I can do this. We will learn in I think next module or following module. Here I have set it, I can do the probability, and so I can do the probability X value. Now here I have probability value. Here I have to do this. So let's say I'm just taking 95%. So 0.025, 0.025, and I hope. So this is 4 sigma value, because 95.44, 4 sigma. So 54 is the highest value. Between 54 to 70, 95% of the passengers were there. So this is just, you know, we are not going into this in deep, but I wanted to explain here. So I'm just going back on my slide part. Here and so I hope you can see this standardized. Now one more thing, which is standardized data. What is standardized data? Here, each value, you know, it is entire, you know, mean of entire data, standard deviation of of entire divided by A, and then individual value xi. Then that data will be converted into standardized format, and I have very simple option in Minitab to do that standardized data. Can you see my Minitab now?
Yes.
Yes.
So under calculate, we have standardize. Can you see this? And I'm just going to do for age column, store results in C12. Here you can see clearly, this is, so 42, which is 30. What is the value of 32 point something divided by So this is standardized. This data has been converted into standardized format. What is the importance of a standardized format? For standardized distribution, mean is always 0 and standard deviation is always 1. Now I'm going to do the same for C12. Look into this graph, histogram. I'm just going to use this, and I'm going to use C12 and look into this. A mean is, very close to 0 and the standard deviation is 1. In a standardized format, always keep in mind that the standard deviation is 1 and this is 0. Now look into, so this is now sigma, 6 sigma. So within 6 sigma, almost every data comes. Therefore, how we can range? So 6 sigma is entire range. So if you know the lowest value and highest value, you can get the range. Range divided by 6, then you can get the standard deviation. So this is very simple calculation. Entire range comes in 6 sigma range. So this is 6 and sigma. If you want to get the sigma, how you do? Range divided by 6. This is another way to calculate sigma very easily. Now we are coming on percentile. So percentile I explained in the video. Again, I'm going to explain here. So percentile, if you divide your data into 100 equal pieces, that is called percentile. If you divide into 10 pieces, that is called deciles. If you divide into 4 pieces, that is called quartiles. If you divide into 5 pieces, that is called quintiles. So these are the different representation, but most important is quartiles and percentile. Why? Because so how we do quartiles and percentiles? So Q2, this is called median. So first you take entire data, take the median. Then second thing you do, you take this lowest 50% and take its median, which is Q1. Second, take upper 50% and do this median. So the data can be divided, and interquartile range is between Q3 and Q1, which is middle part of the data. So this is quartiles, percentile and quartiles. And this can be represented using box plot method. Box plots represent 5-number summary, which is minimum, maximum, Q1, Q2, Q3. And that is how we do the 5-number summary representation in Minitab. So look into box plot. Where is the box plot? Right here. And I'm just going to check this each part, and okay. So this is the box plot. This is the lowest value. This is the highest value, you can see. If I put, you can add the levels also, 74. You can also do it Q1, Q2, Q3, all. So this is 5-number summary. And then we have correlation coefficient that comes from -1 to +1. So what is correlation? R equal to +90 means this is positively highly correlated. This is negatively correlated because one is going up, one is going down. This is medium. So positive, there is no correlation. Relationship between two variables is called correlation. Higher is, so the range of correlation starts from -1 to +1. 0 mean no.
Are you back on your slides?
Oh, slide. Oh, just a minute. Yeah, this is, can you see the
Thank
slide?
you.
Sorry.
Yep.
So this is correlation. Covariance. Now, skewness can also be calculated using Minitab. You can understand from value of this formula, if you get the skewness value in less than 0, it is left skewed. More than 0, right skewed. 0 means it's a normal. Kurtosis means how the peak is there of the distribution. If it is kind of flat, that is called platykurtic, and the value is less than 0. 0 means it's almost normal. If very sharp peak, the kurtosis is greater than 0. Now I'm going to show all these calculations on Minitab. So right here, we have everything. Go under statistics. If you can see my Minitab, go under display descriptive statistics, and I'm going to do this, for example, age again. When you look into the statistics, if you can see my window, I'm just going to do none. Here you have mean, your standard error of mean. Somebody was asking standard deviation. This is right. Variance, coefficient of variation, first quartile, median, third quartile, interquartile range, mode, trimmed mean, sum, minimum, maximum, range, sum of square, skewness, kurtosis. So all you can do, just do it. You get all the numbers right here. And so my purpose was to give you the interpretation. Now here I go under basic statistics where we have normality test. Now I just check the age. Fatima, I'm going to, this is being recorded and it will be uploaded. And similar meeting is already there, which I put, you know, a previous face-to-face MBA class that we conducted through online because of COVID-19. So which is exactly the same. And that has been divided into 2 separate chapters. So you can see both the recordings on the bottom of the, I will show you just, so already there, exactly the same thing, maybe, you know. So here we have, here you can see, and the p-value is right here. So this is, for example, this is a p-value, which is for entire this, you know, age thing. I will explain about this normality, and, you know, because this comes under, you know, normal distribution, standard normal distribution. So this is here also under graph. We have probability plot. No, we have state and graph probability plot. Okay, and then I can do the age. So this is also under this, but only, you know, this is the case. So this is the, you know, chapter 3 and 4. I only ask very simple questions with what is the, you know, for example, from which is, so you don't need to do anything under graph, just do go pie chart, and, you know, I just do the male and female, where is male, just this is the, and you get the percentage 79.7 and 20.3. I did not ask anything apart from that either. Similarly, I asked 4 or 5 questions about lost or survived. So go under graph, pie chart, and I just use joined, not joined, status, survived. This is the survived option. You have all the, you know, what is the survived saved people, and 28.7. But, you know, you just write 28.70. So such kind of question, I did not ask any, you know, just I asked same questions for example, Southampton, or, you know, which, so.
Is this for an assignment that you asked us to do, or is this for the open question quiz?
How would you, you know, this is the same question you have asked. How would you use Minitab to find the range of certain percent of group of passengers?
No, I was just asking, I'm curious if we're using Minitab for any assignments in the course, or is it just to help us get through some of the quizzes and the stuff as far as pertaining to the class? I understand that we need to learn how to use
No,
Minitab.
actually, all the assignments, quiz, all the, all 3, 4 next, whatever module we have, we need, every calculation is done so quickly using Minitab. If you do calculation in Excel or any other tool, that will be, I mean, writing is equation, formula, doing number crunch, and that will be difficult. So we need
Yeah,
Minitab
thank you.
for,
That's all. That was I just wanted to make sure that it wasn't specifically for an assignment we needed to be turning in, because there was such an emphasis on getting it downloaded at the beginning of the course.
yeah. So yeah, we need for quiz and, fill in the blanks and quiz both. So, but I want, I will make some, error consideration in your answer. Suppose somehow, because I got to know about 2, 3 people that they have a problem because of old machine, old computer, they are not able to download, or somehow, they are not able to run. Okay, then I said, okay, use Excel if you have Excel or any other tool, but the difference here, the answer is coming 2-digit, there will be 3-digit, 4, I mean, little bit. So I will set the little bit margin of error. For example, the answer is coming here, for example, 28.7. I will put plus 0.3 plus minus. So suppose somebody will type 29, that will be accepted, and 28.4, that will be accepted. And yeah, within this range, all the tool or all the applications will work. So you don't have to use it. Okay. So Erin, how to set the cut point? You can do it very easily. So I was just trying to do something which I forgot. Yeah, it has, because answering, I was just trying to show you some important thing. Anyway, so yes, let it be. So now what I was, yeah, cut point and midpoint. Okay. So go under graph, we have histogram, and I'm just using, let's say here, age, because it has good numbers. So this is the right here, and you can go under this. So this is histogram, and you can do here edit graph, and undergo edit bars. And here we have binning option. Under binning option, you have cut point and midpoint. So you want to use midpoint or cut point. If you know the concept of midpoints, let's say I'm just doing a age group between 10 and 20. So these 10 and 20, these are cut points. What is the midpoint in between? 25 would be midpoint. So if I want to do, based on cut point or midpoint, I have to choose. So if I want to do midpoints, means which will be the middle point between middle point of the bar. Then, or cut point means those are the boundaries, or points where the bar is cutting, or the limit of bar is going. So I prefer cut point. So let me do this.
Wouldn't midpoint be 15?
Midpoint.
Yeah, wouldn't it be 15 for
Yeah,
age group 10
you
to
can
20?
do midpoint or cut point, either, doesn't matter, but make sure what you are achieving, So for example, here I'm just going to do, I would like to make it 10 years period of, this 10 years period. What is from 0? So first is 10 point, sorry, here are 10. Then we don't need to put comma or something, only space, 20, 30, 40, 50, 60, 70, and 80. So these are my cut points, means up to 10, this will, 10, this will cut. So look into this. Oh, sorry. here you can see, and I can, add data also, data levels. Okay. So here you can see 0 to 10, 93, 10 to 20, 23, 237, here it's 77, and you can see. So only 10 classes with 10, 10, 10 years difference, you can see this. So, and similarly, I can do for midpoint. So just watch this. I'm going to do midpoints also. Winning midpoint. So what would be the first midpoint? Would be 5. Second is 15. Third is 20. Sorry, 15. Yeah. So 5, 15, 25, 35, 45, 55, 65, 75. Is it okay? You will see exactly the same graph. Here you can see exactly the same graph because I just changed the midpoint or cut point. So this is 0 to 10. What is the middle point of 0 to 10? 5. 10 to 20. What is the middle point? 15. So nothing has been changed. This is the concept of midpoint and cut point. Hope, is it making sense? Okay, so this is the concept. What you ask about, what other question you have, please let me know. No question, then I would like to say have a great night. Have a good night and hope you.
I have a question.
Yeah, please type because I can't hear you properly. Probably something. It would be better if you can type, or because here in my building or in office, lot of, those. Let me see if I can increase the volume. This is 100% increased. Please go ahead. Can you show a number of people based on percentage? Are the previous lecture video and module material? Yeah, Fatima, just see here. I'm going to demonstrate to you. So just a minute. News here, and this is where am I? Can you see my this?
Yes.
Yes.
So under this, when you go, I'm just putting under here lecture link. I got it. I'm going to solve your issue. So for here, these are the links I recorded. One time I recorded and probably I forgot to mute or unmute my mic, and all the recordings were recorded without voice. So I did it again, and so you will see also muted over there. So this is full video of chapter 3, full video of chapter 4 of regular campus class that I did in last fall 2020. So these are there. You will see, for next module and everything. How to write range in the fill in the blanks. So very good question. I don't see the file option. I'm going to, just one by one. This is right here, you can see the link at the bottom of the module. After summary, you can see on each, and then this is the one. So Fatima, this is the place where you can see, if you can see my screen, if everyone can see my screen of Canvas, I think this is clearly visible. If not, I don't know.
Yes, I can see it.
Now, yeah, how to range in, for example, yeah, this is good question. So Minitab, and so now hopefully you can see my Minitab again. What is the range? So what do you think, what is the range? So for example, I go under statistics. Here we have descriptive statistics. So can you see my this? This is my data. This is 50% is here. Median is 50%. This is minimum value and this is maximum value. This is Q3. This is Q1. Now you have all the questions. You have number here. All the number. What is minimum is 0.17. Sorry, 0.17. Please bear with my writing because I'm using mouse. Highest is 74. What is median? Where is the median? What is the median? 30 is the median. Q1 is 23. And what is the maximum? Q3 38. You have all the numbers in front of you. Now, whatever question has been asked about range, last few questions in that, you have to think, what am I asking? And you have to give the answer.
No, I understand what the range is. Range is two numbers. The question is, what is the range? It's two numbers, but to fill in the blank, I have to write only digits. How I can write two numbers, writing only digits with no spaces?
So, for example, 99 minus 23. What is the range? So you just subtract, and I ask about the only integer number. So 99 minus, so this is 6.
So it's basically difference between maximum and minimum.
Yeah, whatever, you know, this is the range. So basically this is the range within this
Okay.
numbers are coming.
Yeah.
So for example, look into this interquartile range. Where is IQR 15? What is this? This is this middle area, means this area 38 minus 23. What is this? This is middle 50% data. So this is called interquartile range, which is 15. So this is similarly, you know, you have to. Any other question do you have? Yeah, I get it downloaded, but the licenses, it has been used. Just a minute. So I'm just going to share one thing. Just here. So just look into this announcement part. Getting started with virtual lab. If anyone is having issue, this is the, you know, to start with. For example, right here, this is the description, how to go. Can you see this? It is the way to do this, but I don't think, because the license is not expired. It can valid till, you know, 31st of July, I believe. And so this clearly says, if you can see July 31st, 2021. I don't know if you still face any problem. I would request you to go through IT of EW. They can help you. If any other question, please let me know. Thank you. Bye-bye. Good night. So you will see the recorded thing tomorrow, because it will convert and then I will upload. Most welcome to everyone. Bye-bye.
Thank you.
You're most welcome.
Thanks a lot.
Bye.